In this video, we are going to talk about homogeneous and heterogeneous materials. We will also talk about the difference between elements, compounds, and mixtures. Homogeneous materials, they are the same throughout, and heterogeneous materials are different throughout. In chemistry, we study matter, and when we look at the matter that's out there, we can ask ourselves the question, can it be physically separated? And those that can be physically separated, or you can look and see the different things that make up the mixture, and you can pick them out. You can then separate that mixture out. Mixtures can further be classified into two types of mixtures. And for this, you ask yourself the question, do you have uniform composition, or is it more heterogeneous? So if the composition is uniform, then you would have a homogeneous mixture. And another name for that is also a solution. And you'll hear me use both of those terms, solution or homogeneous mixture, but they mean the same thing. If the composition is not uniform, in other words, you can see different colors, different phases, then you have a heterogeneous mixture. Most things in our world are heterogeneous mixtures. So it's being able to pick out what is a homogeneous mixture and then the pure substances, which we're going to talk about right now. So pure substances, this is matter that you cannot physically separate out, and you can chemically separate it out. If it can be chemically separate out or decomposed, then we have what's called a compound. And if it cannot be chemically decomposed, then we have an element. And how you figure out if you have an element or not is you look on the periodic table, and if it's on there, then it's an element. So let's look at some examples of matter. So with mixtures and compounds and elements. So let's go through each of these, just kind of take a stab. Go ahead and stop the video and see how you do classifying these as mixtures, compounds, or elements. Okay, we're back now. So looking at graphite, graphite is a fancy name for carbon, and so it is an element. Pepper, if you were to look at pepper, you would see color differences, grays and blacks, maybe even some whites. And so because you can see those color differences, then you know you have a homogeneous mixture. Excuse me, a heterogeneous mixture. Let's look at sucrose. Sucrose has a chemical formula, and that is another way to figure out if you have a compound. And so sugar is a compound. And let's look at paint. So paint, if you let it sit long enough, it will actually settle out. And after it settles out, you can see those differences. So because of that, we have a heterogeneous mixture. And last but not least, we have Gatorade. Gatorade, when you look at that, it is a solution. It will not settle out. It is a homogeneous mixture. Let's go and look at elements. As I said before, when you look on the periodic table, those are all the elements. So if you're looking at a name of something and trying to determine if it's an element or not, if you can find it on the periodic table, it is an element. Elements are composed of identical atoms. Um, they are homogeneous or the same throughout. And some good examples of this from our world is copper wire is composed of copper atoms, and we have aluminum foil, which is composed of aluminum atoms. Some other types of elements that you might be familiar with are iron, gold, silver, lead, sodium, and carbon. So if you notice, the abbreviations for these elements are a little bit different, and that's because they are named after their ancient name or their Greek name or their Latin name. And so they've taken that Greek or Latin name and they have shortened it from that. So let's look at also diatomic elements. So so let's look at some elements other elements that so let's look at some other elements that we are familiar from our world. Elements come monatomic and diatomic. Monatomic means that they can exist all by themselves, just a single atom. Diatomic means they always have to have a buddy. So they'll either buddy up with another atom or they're of the same element, or they'll buddy up with another atom of a different element. Let's first look at monatomic elements. So when you look at the elements, uh, the capitalization is important. So the symbol of the element, if it just has one letter, then it's just a capital letter. And if it has two, notice that it has a capital letter and then a lowercase letter. And these are some unique abbreviations because they are abbreviated or their symbols come from their Latin or their ancient name. So we have, first of all, Fe is iron, Au is gold, Ag is silver, Pb is lead, Na is sodium, and C for carbon. So these, again, are examples of monatomic elements or atoms that can exist all by themselves. Let's look at diatomic elements. You do need to have these memorized. There's a little silly mnemonic that has the 7 diatomic elements, and that is have no fear of ice cold bears, and like polar bears. And we have hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. Another way to memorize the diatomic elements is the diatomic elements form a 7 on the periodic table. And you can see that it starts over here with nitrogen and it goes over to fluorine and then down to iodine. I don't know why that's there. Ignore that. Okay. And you might say, well, there's supposed to be 7. I can count 1, 2, 3, 4, 5, 6. Where's the 7th? It's hydrogen over here. So hydrogen is kind of an orphan. It doesn't really have a place on the periodic table, but it is most like this group above lithium, and so that's where it's placed. Those are the diatomic elements. Again, they cannot exist all by themselves. They have to either buddy up with themselves or with another element's atom. Organic chemistry and inorganic chemistry are two different areas of chemistry. In this class, we study inorganic chemistry. Organic chemistry is the chemistry of carbon. So any chemistry involving life, so proteins, DNA, that is all organic chemistry. So inorganic chemistry is everything else. And you might say, boy, we really have a task ahead of us this year, but with the types of reactions, inorganic chemistry is easier in comparison to organic. Let's now talk about compounds. So compounds are also pure substances, just like elements. They are homogeneous. What makes a compound is we have 2 or more elements chemically combined, and they are combined in a fixed ratio. And when you look at how they're combined, they will have properties different from their individual atoms. So a good example of this is table salt with sodium chloride right here. So, and that's another thing that I mentioned before is compounds have symbols like this. So sodium chloride, it has 1 atom of sodium uh, with every 1 atom of chlorine. If you look at just sodium all by itself, it's a shiny metal. And if you look at chlorine, it's a greenish poisonous gas. But when they combine together, we get a tasty treat that we can sprinkle on our popcorn. So again, compounds have very, very different chemical properties in comparison to the elements that make up the compound. So in this reaction I talked about, so we have sodium, the symbol for sodium is Na, and chlorine, the symbol for chlorine is Cl, and don't forget the 2 because chlorine is diatomic. And when you look how it combines, 1 sodium combines with 1 chlorine. Now this is not a balanced chemical reaction, and we're not really talking about balancing here, but you would balance it by putting a 2 in front of here and a 2 in front of here. Balancing is another unit. But what I want you to learn here is that compounds are composed of elements. And as I said before, compounds have a fixed ratio and it's represented in this formula. And for sodium chloride, it would be NaCl. All right, let's have you go through and guess on whether these are elements or compounds. So go ahead and stop the video and go through and identify if these are elements or compounds. Okay, we're back. So the very first one, mercury, we find mercury on the periodic table, so it is an element. And next we have calcium fluoride. So notice that we can hear in the name or read that there's two elements there, calcium and fluorine combined together. So that would be a compound. We have water, and water has a formula H2O, so that's another clue to us that these are elements that are combined. So this is a compound. And last but not least, we have baking soda, which has the formula there. Its scientific name is sodium hydrogen carbonate, and it is a compound. All right, let's now turn to mixtures. So mixtures are two or more things that are combined physically, and mixtures can be solids, liquids, or gases. So here I have two liquids. The first one is, excuse me. So here I have two mixtures. The first one is a liquid, and the second one is a solid. The first one is a homogeneous mixture. And a little clue on if you have a liquid homogeneous mixture is you typically can see through it. So it won't be cloudy, it'll be clear. And next we have our heterogeneous mixture. And as I said before, most things in our world are heterogeneous mixtures. Here we have a rock, and I can see the different colors. I can see the pinks and the whites and the blacks. And because I can see those different boundaries, I know that this is a heterogeneous mixture. All right, so let's talk about homogeneous mixtures first, or solutions. So what is mixed together has very, very small particles, and they will exist in the same phase of matter. So they'll either be all a solid or all a liquid or all a gas. The particles don't settle. Because they're so tiny, they will not settle out. And as I said before, if it is a liquid solution, you can see through it. So rubbing alcohol right here in this picture, this is a mixture of water and alcohol, and it mixes together and forms the solution that will not settle out. Some other examples are brass. These are two or more metals that are melted together, and then they're allowed to cool, and they're then a solid. And because it is mixed evenly, and you can't see where one metal ends and one begins, and it's all their atoms are just mixed together physically, this is a solid solution or a solid homogeneous mixture. And then another example of a homogeneous mixture is the air we're breathing. So the air we're breathing contains mostly nitrogen, but there's oxygen in it that keeps us alive, that we're breathing, our bodies are extracting out of the air. And then we're breathing out CO2. So those are three of some of the components of air, but they are mixed evenly. We don't walk across the room and go from one pocket of oxygen to the next pocket of oxygen. It's just completely mixed homogeneously. So it's an example of a a gaseous homogeneous mixture or a solution. All right, so in solutions, we have what is dissolved, and so that is called the solute. And we have what does the dissolving, that is called the solvent. And water is usually what we use to dissolve things in because it's inexpensive and we find it all over in our world. So here's just an example of taking some sugar and putting in some water and making some sugar water. So this is something that I saw my father do when he was a beekeeper when I was a really little girl. When I was a really little girl, the beehive was right outside my bedroom window, and I could watch the bees come in and out of their hive. And sometimes in the wintertime, they just need a little bit extra food. And so my dad would put out sugar water. But sugar water is a solution with sugar as the solute and water as the solvent. And how I remember these two is I remember alphabetical order, U comes before V, and I always remember that U going into the V. So the solute goes into the solvent. All right, heterogeneous mixtures. So they're different throughout. So you can see some sort of boundary with different phases. So for example, right here, this ice water, I can see where the solid is, and I can also see where the liquid begins. And so because I can see that boundary there between the states of matter, this is a heterogeneous mixture. And I can physically separate my ice water from, or my ice from my water. So you can just get a spoon and scoop out the ice, and then you would be left with a compound, H2O. Um, and the ice is also H2O, but because it's a different phase of matter, then we do call it a heterogeneous mixture. Here's a salad. In the salad, I can see the components of the salad, the reds and the greens, and I can physically separate those out. Milk is a complicated one. You know it's a liquid, and but when you look at it, it looks cloudy. So that's not that clear solution that I was talking about. So sometimes with heterogeneous mixtures, you need to use a microscope to see if there are any differences or to see if it is completely mixed uniformly. And we see under a microscope, we can see um, the fat components of the milk, and you can see that there's different sizes, and we can see that there is a difference there. So milk is a heterogeneous mixture. All right, take a look at these. Go ahead and stop the video and give yourself a quick quiz on if this is a heterogeneous mixture or solution. Okay, we're back now. We have Kool-Aid is a solution. Concrete, because you can see the rocks and the differences in there, is a heterogeneous mixture. Milk, we just went over. That is a heterogeneous mixture because under a microscope it looks different. Fruit salad, also a heterogeneous mixture. Air is a homogeneous mixture, but air pollution added to that would be a heterogeneous mixture. Soda pop is a heterogeneous mixture, and the reason why is because of the bubbles. You see different phases. So you see the gas of the soda pop, and you also see the liquid solution. So because of that, it's a heterogeneous mixture. All right, matter flow chart. Again, here it is. Again, we can separate into mixtures and pure substances. Pure substances, we have elements, which will be found on the periodic table. Compounds are made up of elements. And then mixtures, if it's uniformly mixed, we call it a solution or homogeneous mixture. And most things in our world are heterogeneous mixtures because we see different phases or different colors or different components. So here's some more practice if you need it. So go ahead and stop the video if you'd like to practice some more. Okay, we're back now. Here are the answers. Okay, this concludes these two topics, homogeneous and heterogeneous, and elements, compounds, and mixtures.